Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we're going to talk about types of matrices, okay? So in this video, in the previous video, I talked about, just gave an overview, but in this video, I'm going to give you the types of matrices. And I'm going to show you how, what are the commonly used types or the commonly used types in most mathematical calculations. And because I know there's a lot of matrices, I'm going to only take about 13 or so. When you go to the textbook, you will see more than that, but I'm going to talk about the most commonly used ones, the 13 types. And also that you will also notice that basically matrices, they are basically distinguished based on three things: the order, the elements, and certain other conditions depending on the situation. So, but before I proceed, don't forget to like, share, and subscribe. If you've not clicked the notification bell, I don't know what you're waiting for. All right. So let's get straight into this. So I'm going to basically list the matrices, maybe give some examples, and we'll talk about it. So, but I'm aware that some students do take notes. So I'm going to write down what I said earlier. So matrices are distinguished on the basis of the order of the matrix. I talked about order of a matrix in the previous video. So if you've not watched the previous video, please go back and look at the video again. And also I talked about what is the element of a matrix and how do you determine that. So there are three things that will distinguish the type of matrix. So the order of the matrix, the element of the matrix, and also certain other conditions. So what we have here is that matrices are distinguished on the basis of their order, elements, and certain other conditions. Okay? So we distinguish element based on three things: the order, the elements the matrix contain, and also certain other conditions. So, like I said, I'm gonna just only talk about 15, but there are so many types. So I'm gonna just talk about the 15 most commonly used. All right. Or should I make it 16? It depends. I think it pretty much the other two or three are more they are rarely used except when you're talking about complex matrices. So let's just talk about 13. Let's make it 13, okay? So we're going to talk about 13 commonly used matrices. So we're going to talk about 13, all right? So I think 13 will be appropriate for this level, okay? So, or commonly used or types of metrics. So I'm going to just talk about 13 in this video. All right. So when you go to the textbook, some will show you 20, some can show you up to 17, some will show you 15, but I will just leave it at 13, okay? So 13 the most commonly used one at this level. And when you get to the university and you're going to higher level of analysis, you will see the other types. Okay, good. So let's go. We're going to talk about 13 types. So now I'm going to start with number one. The first one I'm going to talk about is what we call the row matrix. The row matrix, okay? So the row matrix, this is from the word row matrix. So basically, these are metrics with one row, right? So these are metrics with one row. Okay? So for example, we can have a matrix A that is like, let's say 4, 6, and 7. okay? 4, 6, and 7. So definitely this is a 1 by what? 3. So the order for this is a 1 by 3. It has 1 row and 3 columns. So this is a row matrix. So when I say row matrix, it's basically talking about a matrix with 1 row. Now, similarly, the next one is what we call number 2, the column matrix. Now, the column matrix, same thing, but this time it's a matrix with 1 column. Okay, so for example, if you have a matrix, let's say Z, does not really matter. We have this matrix 1 and 20. Or let me make it 11 so somebody will not get confused. 11 and 20. So this is a 2 by 1 matrix. So you can see the number of columns is 1, the number of rows is 2. This is what we call a column matrix. Number 3 is what we call a square matrix. So a square matrix. So a square matrix now, from the word square, remember a square has all the sides are equal, okay? If you remember from the shape of a square, all the sides are equal. So, but for a square matrix, it has equal number of rows and column, okay? So it's a matrix with an equal number of rows and column. Okay? So a square matrix is a matrix with equal number of rows and column. So let's assume we have this matrix B, okay? So let's say we have 3, 4, 7, 2, 8, 1, and 5, 3, 2. Now, this is a what? A 3 by what? 3 matrix, okay? So you can see the number of rows is equal to the number of what? Columns. So it's a 3 by 3 matrix. Number 4, so we've talked about the row matrix, which has 1 row. We've talked about the column matrix, which has just 1 column. Now we've talked about the square matrix, which has equal number of rows and column. Number 4, let's see, let's go to the next, let's say rectangular matrix, okay? So rectangular matrix. So unlike a square, so remember in a rectangle, the sides are not equal. So that means the length and the breadth are not equal in a rectangle. So the same thing here. A rectangular matrix is a matrix with unequal number of rows and columns. So a matrix, okay, a matrix with unequal number of rows and columns. So for example, let's pick let's say N, a matrix N. All right. So matrix N. So we have 3, 2, 5, 1, 8, 1, 8, minus 1. So the number of rows here is 2. The number of columns here is what? 3. So this is what we call a rectangular matrix because the number of rows and columns are not what? Equal. So this is 2, okay? So let me write it better. This is 2. So it's a 2 by what? 3 matrix. Number 5. The fifth type we're going to talk about is what we call a diagonal matrix. Now, this is different from the leading diagonal or the diagonal elements or the main diagonal that we talked about in the previous video. All right, this is what we call just a diagonal matrix. Okay, so please take note of that. So because sometimes some students think that a diagonal matrix is the same thing as the leading diagonal. They are two different things. So please refer to my previous video where I talked about it. Okay, so diagonal matrix. So for diagonal matrix, so basically a diagonal matrix is a square matrix. So now I'm using the word square matrix because the rows and column are equal. But this time that is a square matrix that has where the non-diagonal elements are equal to 0. Okay, so that means any other element outside the leading or the main diagonal is 0. So it's a square matrix. So we've talked about a square matrix already. So a square matrix with non-diagonal. Okay, where the non-diagonal elements here are equal to 0. Okay, so what I'm saying is that, for instance, we have, let's pick a matrix. It does not really matter. Let's say matrix B. Now, this is a let's say 2 by 2 matrix. So we say 3, 0, and we say 0, 5. Now, this is a square matrix because it's a 2 by what? 2. Are you seeing it? Now, but the only difference here is that it's only any numbers that are outside the diagonal elements are 0. So you see, this is 0, this is 0. So that is why it's called a diagonal matrix. Now you can pick another one. Let's assume we're picking a 3 by 3 matrix. So let's pick a 3 by 3 matrix. So let's say H, matrix H, and we have it to be, let's say, 3, 0, 0, 0, 7, 2. Sorry, I'm talking about the diagonal matrix, 0. And we have 0, 0, let's say 9 or 3 or 1. It does not really matter. Okay, so now this is a square matrix because it's a 3 by what? 3. Are you seeing it? But if you look at it carefully, you will see that the only ones that are non-zero are the ones in the diagonal what? Or the leading diagonal. So that means any number that is outside the diagonal element are 0, and this is what we call a diagonal matrix. All right, so number 6. Let's go to number 6 now. Number 6. The next one I want to talk about now, I'm going to talk about the scalar matrix, okay? Now, a scalar matrix is a diagonal matrix. So you can see I'm using the word diagonal matrix here. Now, it's a diagonal matrix, so it's a form of diagonal matrix, but it's said to be scalar if the diagonal elements here are equal to 0. Is that making sense? So that means a diagonal matrix is said to be a scalar matrix if its diagonal elements are equal to 0. So basically, what I'm saying is that it's also a type of diagonal matrix, but in this case, instead of the elements because it's a diagonal matrix because only the diagonal has numbers that are non-zero, and outside all the non-diagonal are 0. But in this case, the numbers in the diagonal matrix are equal. So that's the difference between a diagonal matrix and a scalar matrix. So you can say a scalar matrix is a type of diagonal matrix. So now I'm going to write it down. So a scalar matrix. So this is a diagonal matrix. So a diagonal matrix is said to be a scalar matrix. If its diagonal elements are equal. Okay, so what I'm saying is, if you look at this now, all right, we have 3, 0, 0, 3. Now, you can see that, get this off, write it well, 0, 3. Now, you can see that this is a 2 by 2, it's a square matrix, and also that it's a diagonal matrix because only the diagonal element has numbers that are non-zero. But it's a scalar matrix because if you look at the diagonal elements, they are all what? Equal. So you can see the difference between this. The diagonal elements were not equal. So that's why it's called a diagonal matrix. But when they are equal, it's called a scalar matrix. Okay? So let's pick another one. So let's say we have another, let's say 2, 0, 0. 0, 2, 0, and we have 0, 0, 2. And this is, for example, it's a 3 by 3 matrix, so it's a square matrix, and also a diagonal matrix because it's a square matrix and the diagonal here are equal. So you can see that they are equal here. Okay? Now, but because the diagonals now, they are equal, it's going to be called a scalar matrix. So because they are equal, it's a diagonal matrix. Sorry, because they are non-zero, it's a diagonal matrix. But because they are equal now, it's going to call the what? Scalar matrix. Okay, so I know you will like, oh, there are different types of metrics. I told you there's a lot of metrics. I'm going to just use the most common one, all right? So that we'll talk about that together. So number 7, all right? The next one is what we call the zero or null metrics. So a zero or null metrics is very easy. So basically, these are metrics that all the elements are 0. So it's very easy. So number 7 is a 0. Oh, let me use a capital letter there. So a 0 or null matrix. So basically, a matrix is said to be, so a matrix is said to be 0 okay? So it's said to be a 0 matrix, or you can call it a null matrix. So depending on which you're comfortable with, so it can be said to be a 0 or null matrix if all its elements if all its elements are what? 0. Okay, so for example, if you have H is equal to 0, 0, this is a 0 matrix because it's a 1 by 2 matrix, okay? Or you have B, and B, you have it as or let me use P because I've used B a lot. So let me say P, okay? You have it as 0, 0, 0, 0. So it's a square matrix. Are you seeing it? So it's a 2 by 2 matrix, but it's also a 0 matrix because all the elements here are what? 0. Then the next one, let's say J, you can have it as 0, 0, 0, 0, 0, 0, 0, 0, 0. So this is also a what? A null matrix. So it's going to be a 3 by 3 because you have 3 rows and you have what? 3 columns. All right. And this is going to be a 0 or a null matrix. Then in the same vein, I'm going to talk about number 8, which should be a unity or no, not unity. I mean unit or identity metrics. Okay. So this, unlike the zero matrix, is a square matrix of any order. So it could be a square matrix of any order, means it could be like a 4 by 4, a 5 by 5, a 10 by 10. It doesn't really matter. But it's the diagonal elements only have a value of 1, while the rest of it is what? 0. So that's what we call an identity matrix. So the diagonal element of that square matrix is 1, and the rest of the elements is 0. Okay? So that's number 8. We're almost there. So unit or identity matrix. All right? Unit or identity matrix. So this is a square matrix. Okay? Of any order. Which contains on its diagonal elements with value of 1. Okay, so the value of 1, while the rest of the matrix while the rest of the matrix elements, okay, while the rest of the matrix elements are equal to what? 0. Okay, so for example, what I'm saying is if you have, let's say you have R, okay, a particular matrix. So you have this one, 1, 0, 0, 1. Okay, you have this. So you can see this is a 2 by 2 matrix. Okay, but in this 2 by 2 matrix, if you look at the leading diagonal or the main diagonal, you can see that all the elements in the main diagonal are 1. So this is why it's called an identity matrix or a unit matrix. You can do the same thing. If you want to go with another matrix, let's call it Q. So you have 1, 0, 0. You have 0, 1, 0. And you have 0, 0, 1. This is also another there. So you can see, so far it's a square matrix and all the elements in the leading diagonal is 1. It is called an identity matrix. So this is a 3 by 3 matrix, okay? Then if you check the leading diagonal for this, you see all the diagonal here is 1. So one thing you need to keep in mind is that in this case here, we usually denote the unit matrix of any order as I to n, okay? So we denote, so I'm going to talk about this later. I just want to write it here. We denote the identity matrix of order n, all right, by, so I n, okay? So I'm going to talk about this later. I'm just writing it here. So when you have an identity matrix of an order n, we write it by I to the base n. All right, good. What number was that? Number 8. So let's go to number 9. So the next one we're going to talk about is what we call an upper triangular matrix. So that was the reason in the previous video I talked about upper diagonal and I also talked about lower diagonal, right? So the same thing. You need to look at my previous video where I talked about the upper diagonal and lower diagonal. It's very important here. So we're going to talk about the upper triangular matrix. So upper triangular matrix is a square matrix in which all elements below the diagonal are 0, and this is called a upper triangular matrix. So basically, all the elements below the diagonal are 0. So the next one is what we call upper triangular matrix. So it's a square matrix in which all the elements below the diagonal are 0. Okay? So this is known as what? As the upper triangular matrix. Okay? So for example, let's say we have, for example, we have t is equal to, let's say we have 3, 0, 0, we have minus 2, 5, 0, and we have 5, 6, or 5, 0, 9. It does not really matter. All right. Now, and what type of matrix is this? This is a 1, 2, 3. So it's a 3 by 3. So it's a square matrix, okay, in which the number of rows and columns are the same. Now, but if you look closer at this matrix, you will see that the elements, this is the diagonal or the leading diagonal, okay, of this matrix. But you were told that in which all the elements below are what? 0. So if you look at all the elements here below this matrix here, you see all the elements below it, you see all are what? 0. And that is why it's called an upper triangular what? Matrix. Okay, that's why it's called an upper triangular matrix. In the same vein, let's talk about the lower triangular matrix, number 10. So we're going to talk about the lower triangular matrix. So the same thing, because remember, in the upper triangular matrix, which we said is a square matrix that below is 0, but in lower triangular matrix, the above the matrix is 0 this time. Okay, so it's basically the opposite of the upper triangular matrix. So it's a square matrix in which all the elements above, okay, the diagonal are 0. Okay, so it's a element in which all the elements above the diagonal or the diagonal elements are 0, and this is known as the upper triangular matrix. Okay, so for example, let's say we have W. So we have this matrix here. So we have, let's say, 4, 0, 0. We have 0, 2, 1, minus 1. Oh, no, sorry, 0, 2, 0, minus 1, 5, and 6. We have this, and this is a 3 by 3 matrix. Okay, that's the order of this matrix. But if you look at this, similarly, you look at this is the diagonal of the matrix, or the main diagonal, or the leading diagonal, and 4, 2, and 6 are the diagonal elements. Now, if you look at this, all the numbers, all the elements above the matrix are 0. So if you look at this, everything here above is what? 0. So because everything here is above is 0, it's going to be called a lower diagonal matrix. So let's go to number 11. So we're done with the lower triangular matrix. So number 11, what we have is a single element matrix. So we have a single element matrix. Okay. So this is when you have a single number, or you just have a 1 by 1 matrix, or basically a single number. So basically having one row and one column, okay? So it's a single number. May be regarded as a 1 by 1 matrix. Okay, so that is having one row and one column. So for example, you have y is equal to 4. This is a single element matrix, and this is an example of a 1 by 1 matrix. Okay, so that's what you have there. Now, number 12, very easy. So basically, if you just have one number in the whole matrix, it's called a single element matrix, and that is that for that. So number 12 is what we call equal matrix. So when are two matrices called equal matrices? So two matrices are said to be equal if corresponding elements throughout are equal. So that means if two elements, two matrices are equal, if all the elements in the right order are the same, okay? So that means the two matrices must be of the same order and all the elements there are equal. So basically what I'm saying, two matrices are said to be equal if corresponding elements throughout are equal. Okay, so now, but the two matrices must be in the same order. Okay, so this is a very, very important but. Okay, or I can say, okay, or let me say does. I think that will be more appropriate. The two matrices must also be of the same order. Okay, so both of them must be of the same order. So let's say we have, for example, if Z is equal to, let's call it A, B, C, D, and let's say letter S is equal to 3, 2, 1, and 4. Now, if we're told that Z is equal to S, okay, so if we're told that Z is equal to S, therefore the A must be equal to what? So the A here must be equal to what? The 3 here. Are you seeing it? The B here must be equal to what? 2 here. The C here must be equal to what? The 1. Now, the reason why we can do this is because both of them are of the same order. This is a 2 by 2 matrix. And also S is also a 2 by 2 matrix. So that's the reason why we can directly compare and say, oh, these letters are like this, okay? So because they have the same order, we can do this. And the final one, then D must be equal to what? 4, all right? D must be equal to 4 because they are both the same thing. Now, but if we have two matrices, so we have A is equal to A, B, C, okay? And we have B is equal to 4, B is equal to 4, 3, and 1. So that means A cannot be equal to B, okay? So it's not possible for A to be equal to B because they are different order. Now, when you look at this is a 3 by 1 matrix. So this is a 3 by 1 matrix, while this is a 1 by 3 matrix. So because they are not of the same order, so therefore A can never be equal to what? B. So before the two matrices must be the same thing, is that the must first be in the same order, then before you can now directly what? Compare them. All right, so the last one we're going to talk about is number 13, the singular matrix. So singular matrix, so a matrix is said to be singular if its determinant is 0. So we're going to talk about that later. I'm going to talk about how to find a determinant, but I just want to write this down here so that when I get to that point, I can now just refer to this video for that. So a matrix is said to be singular if its determinant is 0. Okay, so I'm going to talk about that. Yep, and that'll bring us to the end of the 13 commonly used or the types of metrics. And we've talked about each of them. So we've talked about 13 and yep, so I've talked about the row metrics, the column metrics, the square metrics, rectangular metrics, diagonal metrics, scalar metrics, zero or null metrics, unit or identity metrics, upper triangular metrics, lower triangular metrics, single element metrics, equal matrices, and singular metrics. Okay, so we've talked about all this. All right, so the next video, I'm going to talk about the matrix notation, and that's what I'm going to talk about. So it's very important to subscribe and you click the notification bell so that when I post the next video on matrix notation, you'll be the first person to know. And like I always say, if you have any question, feel free to email me and I'll get back to you as soon as I can. So I'm going to see you in the next video where we talk about the matrix notation. All right, see you soon.